Okay, so we talked about elements and symbols, and now we're going to talk even more about elements and symbols, and we're going to introduce the periodic table. So I'm sure you've seen this before. If you have any experience with chemistry at all, then this would be the very first thing you've been exposed to. Okay, the periodic table. So the periodic table organizes a bunch of elements. This one has 118 elements in it. It's about 120 elements. I don't like to make much of the actual number because these ones down here, we just never see it in chemistry. Dysprosium, never seen it. Even that. I don't think I've ever used seaborgium. Never have I used any of these in any questions uh, in a chemistry class, right? So it's about 120 elements. I don't want to make much of the actual number. Now, our learning goal for this section is to use the periodic table to identify groups and periods, okay, and to identify an element as a metal, a nonmetal, or a metalloid. All right, so basically we're going to become familiar with the periodic table here. So now groups, first of all, groups are arranged according to their properties, and they're in vertical columns. All right, so if you have two elements that are in the same column, let's say nitrogen and phosphorus, and I don't know what's down here, nitrogen and phosphorus are going to have similar properties. They're going to have similar properties because they're in the same group, okay? And they're arranged vertically. Now, periods are arranged horizontally, and they do not have the same properties, okay? So, and then we count those periods as rows of the periodic table. For example, here is period 1, here is period 2, here's period 3. See that? Okay, let me get rid of those marks here. I don't want to use those right now. All right, so periodic table, and I just want to walk through it, I guess, a little bit more. Let me point some things out here. Notice, please, that we've got alkali metals here. We've got another slide coming up. Alkali earth metals here, halogens here, and noble gases here, okay? Yes, there is a name for that group, but it's not as common. We don't use it as much. There's a name for that group. We don't use it as much, right? So these four groups, I'm going to show you some things about those. And the period number, here's period 1. I think I said that a second ago. Okay, so let's move. Oh, yeah, one more thing I want to point out about this. The nonmetals are all in yellow. Do you see that? And the blues are all metals. Can you see that the vast majority of the periodic table is made out of metals? Most of it's blue, right? It's the vastest majority of it is metals. And metalloids sort of don't fit in either category. They're the green things along here that we call metalloids. Be careful now. Some periodic tables have these particular green ones as metalloids. Some people might not have astatine as a metalloid. So sometimes it's just these 5 that are metalloids. So either way, just be advised that when you get close to this sort of horizontal, or rather diagonal line right here, the difference between metalloids and metals sort of grays a little bit, becomes a little fuzzy. And that's what that's about. All right, so group numbers are written at the top of each vertical column in the periodic table that I showed you, and we're going to call those 1 through 8, and they're A. We call them A for the representative elements and B for the transition elements. All right, so I'll show you. Let me go back and forth a little bit, okay? So these are all B's down here. 1A, 2A, 3A. Can you see that? Furthermore, there are 2 kinds of numbering systems. An alternative numbering system uses 1 through 18 for all of the groups. I'm going to go back to that of the slide now. Ready? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right? So there's 2 numbering systems here. There's the red, right? And there's the yellow, okay? And the yellow numbering system is probably the more common, but since they're both really commonly used, I feel like I should show you both, right? So those are the 2 numbering systems, and I don't think there's anything more to say about that. You're just going to get used to, I think, those numbering systems, all right? And you'll have the periodic table when you have it, right? So it's no big deal, I think, but just be advised, we are going to use those. All right, so because both systems are currently in use, I already said this, we're going to use both of them. And I guess another point I want to say again is vertical columns. Where am I here? Let me go here. Vertical columns represent groups, and horizontal rows represent periods, which I've said a couple times already. All right, let's go back now and look at a particular group, alkaline metals. The first group in the periodic table is lithium, sodium, potassium, rubidium, and cesium. That's group 1A. Let me go back to the periodic table and show you those. They are right here. Right? Lithium, sodium, potassium, rubidium, and cesium. Okay? And francium's down there too. Right? You see that? And these are called alkali metals. It's group 1A. And I don't think I want to say anything else about that. They're very reactive metals, and we're going to see them a lot in chemistry. Okay? The next group over is alkali earth metals. They're the second group over. Alkali earth metals, beryllium, magnesium, calcium, strontium, barium, and radium. They're not as reactive as the group 1A metals, but they're pretty reactive. Okay? And they're metals, right? So they're shiny, and they're malleable, and so on. Let me go back over here. I'm going to go back to the periodic table and show you where group 2A is, just right where you would think it is. Group 2A is here, and the slide I just showed you was beryllium, magnesium, calcium, strontium, barium, and radium. And those are the, can you see that there? Alkaline earth metals. Alkaline earth metals, all right? The next group I want to show you is the halogens, and they are fluorine, chlorine, bromine, iodine, and astatine. Chlorine's green, iodine's purple, bromine's red, and I don't know what color fluorine is, never used it. So these are the halogens, okay? And they're nonmetals. Let me go back up to the periodic table and show you where those are. They are here. There's fluorine, chlorine, bromine, and iodine, right? Right there in the halogen. See that? Okay, so again, you're going to have the periodic table, so you don't have to memorize these, but I want to orient you to it. I want it to be easy for you. So let's do a learning check. First of all, identify which of these, identify the elements described by each of the following groups or periods. Pause the video, pull the periodic table out, and do a little hunting. Okay? Okay, so I'm going to suppose you paused it. Group 7A, so there are two elements in group 7A, but only one of them is in period 4, right? So I don't even know which one it is. Let's go back up here. Period 4 is here, right? I'm really destroying this periodic table. And there's group 7A, right? And there it is, bromine. Okay, so hopefully you got that right. It's not chlorine, that's in period 3. That's in bromine, that's period 4. Now, group 2A is beryllium, boron, and magnesium. Well, I know boron's not in group 2A, but beryllium is, and magnesium may be. Yeah, I think magnesium is in group 2A, but we want to know what's in period 3. So let's go back up here to the periodic table, and here's group 2A right there, right? And here's period 3, and there it is, magnesium. Okay? So where was I? Magnesium. Oh, I don't want that one. This was the one I want. I don't want that one. Lost my place. Okay, there we go. Yep, so it was magnesium. It was not beryllium because that was in period 2. It is magnesium. Okay, and then finally, group 5A in period 2 is nitrogen. I'm sure of it, but I'm going to go back up here. What a mess this is. I'm going to erase some of this off of here. Group 5A, okay? Group 5A is here, right? You see group 5A, and here's period 2, and it looks like it's nitrogen, okay? So let's go back over here. Group 5A is, in period 2, is nitrogen. All right, so now let's talk about metals, nonmetals, and metalloids. The heavy zigzag line between the nonmetals and the metals is got elements that are on that heavy zigzag line, which don't really act like nonmetals or metals. They sort of share properties, okay? For example, metals are shiny. They're ductile. It means you can draw them into a wire. You can pull them, and they'll stretch out. And they conduct heat and electricity. They're solids, except for mercury, which is a liquid, okay? And nonmetals are located on the right side of the periodic table. They're the yellow ones over here, right? They're dull, brittle, and poor conductors, and are oftentimes good insulators, okay? They have low densities and low melting points. Metalloids are sort of in between, right? They exhibit properties of metals and nonmetals, okay? and they are better conductors than nonmetals, but not as good as metals. And they're oftentimes used as semiconductors and insulators because they can be modified to function as either, which is kind of cool. We need that for computers. All right, so here's some characteristics of metals, metalloids, and nonmetals. Here's a metal, silver. It's a metal. It's shiny. It's extremely ductile. You can draw it out and you can stretch it. It can be hammered into sheets. All right, you can flatten it, like sort of stretching it also. It's a good conductor of heat and electricity, and we use it for things that you know about. It has a high density. This is interesting, right? Look at this density, 10.5 grams per mil. It has a high melting point. Look at that, okay? So a non-metal is over here. Sulfur is a good example of a non-metal. It's dull and yellow. It's not shiny. It's dull. It's brittle. It would break if you try to stretch it. And when you try to hit it with a hammer, it doesn't go on into sheets like Play-Doh. It shatters, okay? It's a poor conductor of heat and electricity, and it's a good insulator. And it's used in gunpowder and such, right? And look at this. Look at its density. I overused that highlighter right there. Let me get rid of some of this here. Let me use the highlighter just for the density, 2.1 compared to 10.5. Wow. 5 times as dense is silver. 5 times as dense as sulfur. And its melting point, look at that. Wow, way lower. Like 9 times is low, right? Okay. So let's look at a metalloid now. Antimony. It's really probably not fair to ask you to think about antimony because we've probably never seen antimony, right? So it's blue-gray, and it's shiny, like a metal, right? It's brittle, like a nonmetal. It shatters when hammered, like a nonmetal. It's a poor conductor of heat and electricity, like a nonmetal. And what do we use it for? Here's some things we use it for. And interestingly, it has a density that's in between, right? 10.5 and 2.1. This is 6.7. And it has a melting point that's in between also, 630. Still pretty high, right? All right, so let's do a learning check now, and then we'll move on to the next topic. So first of all, pause the video and identify each of the following elements as a metal or non-metal and check my answers, okay? All right, let me suppose you paused it. I really should have a parent table up here, shouldn't I? Sodium is okay. All right, look at this. Sodium is here. So it's blue, so it's a metal, right? That's a metal. I'm gonna go through here. Now we can do them one at a time. Chlorine. Chlorine is here. Right, so it's a non-metal. Right, I'm not gonna go back and forth anymore. Silicon is a metalloid. Isn't that right? Actually, I just said I wasn't gonna check, but this one, these metalloids are sort of different in different periodic tables. There's silicon right there, so yes, it's a metalloid. And iron is a metal, and carbon is a non-metal. Okay, let's do the same thing here. Check your, pause the video, answer these questions, come back and check your answers against mine. All right, I'm getting sick of going back and forth here. Metals in group 4A. So let's first of all get rid of everything in group 4A that's not in group 4A, okay? Metals in group 4A. I'm just going to actually, just come here. Metals in group 4A. So let's erase these. Here's 4A. And it looks like the metals are simply tin, lead, and FL, whatever that is, okay? Tin, lead, and FL. Tin, lead, that's not a metal, that's not a metal, and that's not a metal, okay? Tin and lead, okay? What about nonmetals in group 5A? Non-metals in group 5A. So here's 5A. It looks like it's only nitrogen and phosphorus, right? Because arsenic's a metalloid, and antimony is a metalloid. So it's just nitrogen and phosphorus. That was easy. Nitrogen and phosphorus, okay? What about metalloids in group 4A? Aha. Metalloids in group 4A. So let's go back up here. Get a little bit busy here. Boom. Metalloids in group 4A. Well, here's 4A again, right? So it looks like it's just silicon and germanium. All right, silicon and germanium. And that's it, okay? Silicon and germanium. All right, so hopefully that's a nice introduction to the periodic table. Get used to looking at it. Get used to referring to it, right? You're always going to have it. Don't memorize it. Just get used to it. That's the whole goal of this section. So hopefully that's helpful.